Hi, my name is Daniel Salom and today I'll be guiding you through this LabVIEW tutorial. Today we'll be talking about basic structures. This tutorial will cover for loops, while loops, case structures, and flat sequences. The for loop. The for loop is a subdiagram that can run a specific number of times that you will set. You can also get in the iteration terminal the number of times that subdiagram has run -1. If you have LabVIEW 8.6 or later, by right-clicking in the border you can also add a conditional terminal. The while loop. The while loop is also like the for loop, a subdiagram that will run, but this one will run until a condition is met. In the iteration terminal you also get the number of times that the subdiagram has run -1, and it will only stop until the condition is met. The condition has to be either true or false. The case structure. The case structure is a structure that will let you run a subdiagram depending on which condition was met. Is it either true or false? It can be either numeric, as in 1, 2, 3, and you can have multiple cases depending on if you use a true or false input, a numeric, a string, or a error or no error using an error cluster. If you use true or false, as we're looking at right now, you only will have 2 subdiagrams to run depending on which condition was met. If you look at the numeric input, you will have more than 2 cases, and depending on which number is in the input, the case will run. Of course, if you have 1, you will have to create a case number 1. But if you have a 7 in the input and there's no 7, then it will run the default case. The case structure with a string will run the same way it will run with a numeric input. And the case structure with a conditional terminal. If you have a conditional terminal and you wire a error cluster in your case structure, you will only have 2 cases: if there's an error or if there's no error. So if there's no error, you will run your process as it would run normally, but if there's an error, you would skip that process and go to the next one, or skip the process and stop the VI. Okay, so here I have a for loop with a 5 wired to the count terminal. This for loop will run 5 times. First, I will add a shift register. Then I will add a add function, a constant here with a for. This will be wired to this side and this to the end of the shift register. I'll here create a constant with a 2. Now we're ready. I will turn on highlight execution so you can see how it works. First it will add 2 plus 4, and that result will go to the next iteration here, which is 6. Then 6 plus 4, 10, goes to the next iteration, 10 plus 4, and so on until the iterations are over. So now you can add a conditional terminal by right-clicking and clicking on conditional terminal. Let's now create a while loop. You right-click, go to structures, and choose while loop. Click and drag to make the size you want to, and there you go. So we're going to do the same thing. We're going to create shift registers, but this time we're going to use multiplication. And we're going to multiply everything times 3. Okay, whenever the output of the multiplication is equal to 343, then the while loop will stop. So this number is past 343, so we'll never stop. Now, I can choose to add another condition. First I delete this wire, go to Boolean and choose OR. And I'm going to choose from comparison palette greater than or equal. So if the iteration terminal is greater than or equal to 6, the while loop will stop. If you want to clean your diagram, you can click on clean up diagram. But that is not going to let us see as well what's happening in the while loop. So Control C to go back. With the OR function, if either of the inputs is true, the output will be true. So either one has to be true for the while loop to stop. The condition was met, so the while loop stopped. Now we're going to create a case structure. We'll go to Programming Structures and Case Structure. You're going to create a constant, and you're going to create a, let's just create a constant in each case. Then add a multiplication. And another constant. So we're going to perform 2 multiplications in each one, but only one will run, depending on what's the input of the conditional terminal. So if it's true, it's gonna be 2 times 3, and if it's false, it's gonna be 2 times 2. We turn highlight execution and we run it. It ran false, so it was 2 times 2 equals 4. Now, which is true, is 6. Now, if you have an error cluster, you can wire it to the conditional terminal, and you see that from true in the current case will go to error or no error. You see? So if there's no error, it will run normally. Not in this. If there's an error, it will run different. So for example, I could go to application control and use the stop function, create constant true, and in the no error it couldn't run normally with nothing in the inside. So if there's an error, the VI will stop automatically and all the VIs and run with it. Now let's go to the sequence structure. To add the sequence structure, you go right click and click on flat sequence structure or stack sequence structure. I'd rather use the flat sequence. You create one. To add more frames, you right click in one of the borders and click add frame. So for example, if I have 2 while loops that you don't want to run in parallel, but they cannot be wired together, so there's no way to enforce data flow and the order of execution, you can put them in a sequence structure, and once one of them has stopped running, the other one will start running. Going to write equal, I'm gonna create a shift register here. Create a constant. Multiply by 3. And whenever that value is equal to 27, the while loop will stop. Let's use 81. And that's how you use a flat sequence structure. Thank you for watching this LabVIEW tutorial.